Hello, everybody. Welcome, Orbit people. I'm Jacob. I work on the Ignite team at Protocol Labs, and I'm here with Raul, Anton, and Dirk, and we're going to be talking about the work that we've been doing this year on improving deal making in Filecoin. And so, as part of this, here's a quick overview of our agenda. We want to talk about the work that we've been doing over the past 6 months or so, and the work that we're going to be doing going forward, what improvements we've made thus far, and what improvements we're looking at making for the future of deal making on Filecoin. So kind of over the past 6 months, we've been working a lot on improving the underlying stability. Our goal is to get to a success rate metric of 99% on the network. In this graph here, you can kind of see deal making on Estuary, deal success on Estuary over the past several months as Estuary has kicked off. Raul will be showcasing this a little bit more on how and exactly where our launch has impacted that. You can kind of see it here in the progression, but this kind of showcases the work that we've been doing. A lot of the initial work on Dagstore, the storage provider runtime architecture, data transfer stability has really been around making sure that the functional layer of Filecoin deal making is working very well and that it's stable. Something that we've noticed after making this and releasing the Lotus 1.11 version is that we've kind of hit a threshold here of stability starting to work more. We're still fixing things every day, but one of the issues we're experiencing here is that we're starting to see a lot of usability problems, making sure that clients and storage providers are able to make deals when they're ready to, making sure that deal transfers are reliable enough and that folks are able to move data when they want to, and also performance. A lot of the work that we've been doing today on GraphSync has been around fixing intermittent issues. Because we've fixed so much around deal making, we're starting to max out what the GraphSync protocol was originally built to be able to handle. And so we're kind of looking at what the future of data transfer also looks like on Filecoin, whether it's improving stability of GraphSync itself and performance of GraphSync to allow more connections and more transfers, but to also open up potentially other transfer protocol mechanisms. And so we're going to be talking a little bit about that more today. And so I want to go ahead and hand it off to Raul to talk about the work that we've been doing on the Dagstore.
Hello, this is Raul, and I'm here to talk about the Dagstore. The motivation why we introduced the Dagstore is that we conducted extensive test ground-based profiling on the deal-making processes, both on the client and the provider sides using Lotus. We realized that there was a large performance bottleneck coming from Badger, which is the IPLD, which is the data store that we were using to stage IPLD data as we were moving it around between the client and the provider. And this performance bottleneck was actually even visible for small data volumes. Now, this Badger is a great database, but the issue here is that we were using it for the wrong workloads, for workloads that it's actually not well suited for. And the reality is that monolithic LSM tree databases do not scale very well for petabytes of granular, very fine-grained data that needs to be accessed with random access. So in short, the data store that we picked was great, but we weren't really being mechanically sympathetic with it, with our access patterns. And then we had a key insight. Data in Filecoin is actually stored at rest as CAR files. So could we read from those CAR files and write to them directly? Could we do better? And this led us to explore the design space. And we came up with alternative solutions. And the one that we ended up converging towards is the Dagstore. The Dagstore is a sharded store to hold large IPLD graphs efficiently, where each graph is packaged as a CAR file. And these CAR files can be attached and detached in a location transparent manner and dynamically at runtime. They can come and go. And all of this is performed with mechanical sympathy, which means that we are being really sympathetic with the underlying access patterns and making the OS and getting help from the OS to actually access that data efficiently. So what were the results? We shipped the Dagstore and MRA, which Anton is going to be talking about in Lotus 1.11. This was around about the end of July. And here you can see a graph of estuary deals, and it's of estuary successful deals made over time. And you can see that shortly after we launched this new version of Lotus, including these two features, the success rate just went up on a steep incline. So we're very happy about that. We think we're on the right path. And just to give you a little bit of insight for the curious people, for the curious minds on what the Dagstore, on how the Dagstore actually works. The Dagstore is a synchronous, concurrent, and event-driven component, and it's built for high performance. As I said before, it's mechanically sympathetic with the underlying OS and the IO, and it's using techniques like M mapping and caching to achieve this. Now, as I said, a key concept in the Dagstore is the shard. And what is a shard in Filecoin? A shard is basically a deal. It is a package of data that is referenced by a unique key. And in Filecoin, this is the deal. Every deal becomes a shard in the Dagstore. Now, the payload of the shard is a CAR-V2 file, or it could be an unindexed, it could be indexed or unindexed, and the Dagstore is also capable of processing unindexed CAR-V1 files. The main shard operations are register to register a shard, acquire to acquire a shard for reading, release to release a shard, and destroy to destroy a shard. Now, shards are location transparent, which means they can be attached through various mechanisms. Like Lotus, file system, and other types. This component, the state of the Dagstore survives restarts because we persist the state on disk. And we also have mechanisms like GC to reclaim local disk space safely and efficiently. And we also introduced a top level index on the Dagstore to allow us to do shard routing just based on a CID of a block that we know is present in some shard, but we don't know which one it is. And now over to Anton to talk about storage provider runtime architecture. Thank you.
Okay, hello. So I'm going to talk about the storage provider runtime architecture. To give a bit of background on the project, I have to explain how Lotus Miner worked before this endeavor. So before the storage provider runtime architecture project, the Lotus Miner process was running all Lotus Miner subsystems within a single process. Namely, these are the sealing, the proving, storing of sectors, as well as deal making. All of this was running within a single process monolith on miners systems. So the goals of the SPRA project were to split the markets subsystem from the Lotus Miner monolith, and in the process, increase robustness and resilience. Storage providers should not have the stability of deal making affecting sealing and proving of sectors, because due to the economics of the Filecoin network at the moment, sealing and proving of sectors is more important to miners than making deals with clients. In the process, we also reduce the attack service because the sealing process does not need to be exposed on the internet anymore. Only the markets process needs to be publicly available and to allow for connection from storage clients. We also wanted to reduce the complexity and spread the knowledge of various subsystems of Lotus Miner within the Protocol Labs organization and the community, and also make it easier to onboard new developers on the project within smaller pieces of functionality within the Lotus code base. So here you can see a diagram of how the various processes of Filecoin Miner interoperate today. So after the SPRA project got merged, the market subsystem became a separate process, communicating with the sealing miner node and the Lotus full node. On this diagram, you can see it as a light blue rectangle, and it's behind the firewall and the load balancer, basically available on the public internet so that the markets can communicate with the storage clients. Lotus Daemon, of course, is also available on the public internet because it's syncing the chain. However, the sealing and the proving node no longer needs to be exposed, which reduces the attack surface. We have also laid the foundation so that the markets process can also be independently scaled in the future, if necessary, from the sealing and the proving node. You can find documentation on the storage provider runtime architecture on the Filecoin docs website, where we explain in detail how you can split your Lotus Miner monolith setup into individual processes, and in the process have reduced operational complexity. You can still use the monolith setup today, though, and we'll continue to support this in the future. If you're interested in the actual code, you can also find the merged pull request in the Filecoin project Lotus repository. You can see that that's the 6356 pull request merged a few months ago. So why is this important? Basically, we wanted to refactor the Lotus Miner monolith as part of this project in order to increase robustness and resilience of the system, reduce the possible attack surfaces, and no longer have the sealing and the mining node exposed on the public internet. We also wanted to reduce the operational risk that miners bear. Nowadays, it's no longer necessary to basically run the market subsystem as part of the Lotus Miner. So in case something goes wrong with storage or retrieval deals, this is not affecting any of the proving or the sealing functionalities of the miner. We also wanted to be able to make to introduce new features to the miner more easily and independently of critical functionality like sealing and mining. We wanted to be able to horizontally scale the market's subsystem and introduce failover. And last but not least, we wanted to spread the knowledge of the Lotus Miner within the organization and be able to onboard new developers and extend the code base further in the future faster. So next, I'm going to hand over to Dirk to talk about the data transfer improvements.
Hi, my name's Dirk. I'm on the Ignite team, and I'm going to be talking about data transfer improvements and some of the upcoming changes we're making for markets. So much of this year we've spent working on performance improvements for data transfer and reliability improvements. So one of the main changes we made was for data transfers to detect when the connection goes down and to be able to restart automatically from where they left off. We reworked the accounting system for retrieval payments so that the way that payment vouchers were processed didn't cause blocking anymore. We did some refactoring in the GraphSync transport. That's the part of the data transfer system that connects with the GraphSync protocol. And Hannah did a lot of work to improve GraphSync memory usage and reliability. So looking towards the future, as Jacob said at the beginning, we've sort of improved performance to the point where we're starting to surface some UX issues. So we're going to be focusing quite heavily on UX and extensibility of the markets process. So in particular, we want to make it easy to manage the state of a storage deal. So we'll be providing UX components, and we'll also be making the whole system more pluggable and easier to control by individual providers. We're going to make the deal acceptance filter more extensible so that it can have more parameters when it's deciding whether or not to accept an incoming deal. we want to make the data transfer protocol pluggable. So at the moment, we use GraphSync as a data transfer protocol, but some groups have been working on other systems, so it should be easy to plug those systems in. And we also want to improve the observability of the whole system, and in particular, what's happening with your storage deal. So as I said before, we want to make some UX improvements. So these two diagrams are really just some ideas we have. They're not solid proposals, but as you can see, we want to make it easy for providers to see how much they have in each fund state. So whether deals are reserved for ongoing deals, if they're locked by the storage market actor. And we also want to make it clear in the UX when to stop accepting deals because the funds are running low. And then on the right-hand side, there's some diagrams with similar concepts. We want to make it very clear when a provider can stop accepting deals because they're running low on staging storage space. And we want to sort of list all the ongoing deals, the states they're in, and make it easy to click into a particular deal and see what's going on at the deal level as it's going through each of the states that it needs to go through to make the deal. So the overall idea is just to improve visibility into the like what's going on with my storage provider and when I'm going to be needing to top up my funds or make more space in my hard drives. So now I'm going to hand back over to Raul, who's going to talk about the Dealbot.
Hi again. So I just wanted to talk a little bit about the Dealbot. The Dealbot is an automated deal-making machine that we've been using at Protocol Labs to measure deal success rate throughout the network. And it's been instrumental in validating the improvements and bug fixes that we've been making to validate whether they've led to high success rates or not. I wanted to send a shout out to the data systems team at Protocol Labs because they actually built the Dealbot, and I'm just here to talk quickly about it. Now, the next thing that I wanted to talk about as well is reputation systems. We have the Filecoin network has over 3,400 storage providers by now, and this is wonderful, but it also comes with challenges. From the viewpoint of the user, how does a user choose which provider to pick for a given deal? That is like one of the key challenges right now, and users can be interested in many parameters when selecting a provider, like reliability, latency, availability, their region. The good news is that the ecosystem has partially already solved this problem, and apps like FillRep or the Textile Bitbot and SPRA are continuously probing and measuring the quality of service of providers using their own methodology. And some of them actually publish scores publicly. However, these scoring feeds are not unified or traceable. And the Filecoin community is working hard on standardizing an open protocol for sourcing these quality of service measurements and observations from deal makers, all the way through to enable reputation providers to run their own models and post back scores, recording all of this information on-chain and providing endpoints for deal-making clients to visualize scores and list providers and sort providers based on their score, and ultimately choose a provider for a given deal. This work is being led by the data systems team, again, at Protocol Labs. Now over to Jake for closing remarks.
Awesome. Thanks, everybody. It's been a great year of Filecoin. We're super happy to be celebrating the anniversary with everyone. A few things that we want to touch on a bit. If you are running Lotus and you have yet to split your miner and your markets processes, we strongly encourage you to do that. You can check out the Filecoin docs on overview how to do that. Let us know if you have any issues doing that. It's a great way to protect your miner and also benefit from all of the improvements that we've made in the storage provider runtime architecture updates. Also, we're going to be reaching out to folks and soliciting the community to get more feedback on the Markets V2 UX. So please, once you see that announcement, please reach out. We'd love to hear from you and help us make deal making easier than ever, which is the path for us to really get to 99% and build a awesome network for the future. So thank you all very much, and happy anniversary. Woo!